So welcome back. There was a technical snag again. I don't know the reason why. So we were again discussing related to the pitch diameter, which is the theoretical mean value between the major and the minor diameter. Okay, so after pitch diameter, you should know what you mean by the lead angle. So on a straight thread, so straight thread or the parallel thread, it is speaking related to the helical groove on a cylindrical body. So on a straight thread, the lead angle is the angle made by the helix of the thread at the pitch line. So where you have the pitch line, so there the angle is being associated and that will be perpendicular to the axis. So that is called as the lead angle. So it is formed, lead angle is the angle made by the helix on the thread at the pitch line. So at the pitch line you will get the lead angle. So this is the pitch line. So at the pitch line you will get the lead angle when you have an longitudinal axis perpendicular to it. So that you call it as the lead angle. So here you will be having an helix of the thread across the pitch line. So across the pitch line you will be having a plane perpendicular to axis. We have to draw and show that exactly. So that angle formed will be called as an lead angle. So next you should know what you mean by helix angle. So on the straight thread, the helix angle is the angle made by the helix of the thread at the pitch line with the axis. So this is along the axis, and if you measure the angle perpendicular to the axis, then you get the lead angle. So if you measure parallel to that of the coaxial axis, then the angle what we get will be the helix angle. So you should be knowing the difference between the lead angle and the helix. Helix angle will be measured parallel to the coaxial axis of the thread, whereas here it will be taken with respect to the plane perpendicular to the axis. And then you should know what you mean by the depth of the thread. So this is the distance from the crest or the tip of the thread to the root of the thread measured perpendicular to the longitudinal axis, or you can also define this as it could be the distance measured radially between the major and the minor cylinder. So this is the depth of the thread. So I defined you already the depth of the thread, right? So the radial distance from the pitch line to the crest and the radial distance from the pitch line to the root which has been truncated. So this entirely gives you the depth of the thread. This is also called to be the pitch diameter, that has been explained you already. So next is axial thickness. So this is the distance between the opposite faces of the same thread. So each helical groove will be having two opposite sides, right? So this is one of the opposite straight edge, and this is one of the opposite straight edge, what we call it as the flank. So the distance between two opposite straight edges will be giving you the axial thickness of the thread. And after knowing what you mean by axial thickness, so then you should be knowing what you mean by the fundamental triangle. So usually the fundamental triangle, if you join A, B and C, so this is formed by extending the flanks and joining the point B to C. So if you extend the flanks and join B to C, so the triangle which is formed is called as the fundamental triangle. So if you name this as A, B and C, you call that as an ABC is the fundamental triangle. Next is truncation. Related to this, I told already, the given screw thread could be a full version with the apex, or it could be truncated at the crest as well as the root. So if it is truncated, so that part is called to be as the truncation. It could be either at the top of the groove or at the bottom of the groove. If it is truncated at the top, you call it as crest truncation. If it is truncated at the bottom, you call that as a root truncation. And then addendum. So this also explained you. So for an external thread, this is defined as a radial distance between the major and the pitch cylinder. So major cylinder or the major diameter. So this is the major diameter, the upper part, and this is the pitch cylinder line. So the distance between the major diameter to that of the pitch line or the pitch cylinder. So this part is called to be as a addendum, and this is called to be as the dedundum. So dedundum is also the radial distance between the pitch and the minor cylinder for the external thread and or for the internal thread. So this is called to be as the dedundum. And major diameter I explained you already, which touches the crest of the internal thread or the external thread. This is also called as the major diameter. So minor diameter, it is the diameter what we achieve, right? So when it touches the root of the external thread or the internal thread, then you define that to be as the minor diameter. And along with this, you should know what you mean by the effective diameter. So in case of a straight thread, means you're using a uniform section of a cylindrical object. So this is the diameter of the pitch cylinder exactly. I told you the pitch cylinder, the pitch diameter will give you the theoretical or the mean diameter between the major and the minor. So this will provide you the effective diameter or the pitch diameter. So both are the same. Sometimes if they ask you like effective diameter, you should not get confused. It is similar to that of the pitch diameter. Okay, so this is the most important dimension which is being needed, which helps you to define the fit between the given screw and the nut. So based on the effective diameter, you can identify how good the fit is between the given screw and nut. So this is one of the terminology which has to be evaluated very accurately to know the performance of the fit assembly between the screw and the nut. So these are all the terminologies. So if they ask you in the examination to explain the terminologies with a neat sketch, kindly draw the sketch and explain each terms. What does it mean? Okay, so next we should come to know which are the measuring elements of a screw thread. So we now studied all the terminologies associated with the screw thread. So here we have to see which are the elements which are measurable. So the measurable terminologies in screw thread are the major diameter, minor diameter, effective diameter, or else it is also called as the pitch diameter. You have to measure the pitch, the flank angle, and the thread form, how it is. So these are all the measuring elements in a screw thread. So in order to measure all these, there are many instruments what we use. Okay, so let us start up with only major diameter first. So we have defined what you mean by major diameter already. So it is the imaginary diameter of the thread which would touch either the crest of an internal and the root of an external thread. So here this major diameter can be measured by two types of micrometer. So one is the ordinary micrometer and other one is the bench micrometer. Okay, so for measuring the major diameter of internal thread is usually done by the thread comparator fitted with ball ended styly. So this is the commonly used technique, so which will be you acting as a comparator. Okay, so let us start up with the ordinary micrometer. So this ordinary micrometer is used as a comparator. Regarding comparator, we have explained in the class already, so which is used in order to get the nearest value. So it helps in comparing the given component with respect of a standard and know its dimension and also the difference between the standard and the unknown component. So here the micrometer is used as a comparator in order to measure the major diameter. Okay, so this micrometer is first set over the cylinder standard. Okay, so in this normal micrometer, this is an hand micrometer where you will be first clamping the given cylinder. So this is considered as a standard, and this standard is called as a setting gauge. So by fixing this setting gauge into the micrometer, you will just measure the dimension of it. What is the value of major diameter? Then you will remove this cylinder, which is the standard, and you replace the component in which you need to determine the major diameter, and you will get the value D2. So you will be knowing what has to be the basic standard size. So depending upon the standard size what you are using of the cylinder, you will write the standard dimension, and plus D1 what you got for the major diameter, and again D2 what you got from the helical groove which you have to measure. So taking the difference of it will provide you the value of D. So this is the way in which it is being used to determine the major diameter by an ordinary micrometer. So same thing will be now measured by using a bench micrometer. The previous one was a hand micrometer. So in order to overcome the difficulties associated in it, the bench micrometer came into picture. So you will be having two centers which will clamp the given cylindrical object to determine the major diameter of the helical groove. So here it is provided with a vernier scale. So after clamping you can take down the reading. So the bench micrometers were designed by a company called NPL in order to remove the deficiencies which was having with respect to hand micrometer, because we were not able to get the accurate one that was overplaced by the bench micrometer. So in this, what was happening, and this instrument is capable of providing you an accuracy of 0.002 mm. So this instrument can also be used as a comparator to avoid the pitch errors of the micrometer threads and also zero error setting. So this instrument could be used as a standard to compare with that of the cylindrical object whose major diameter has to be determined. So it helps in overcoming the pitch errors of the micrometer threads, and also zero setting errors could be overcome, because this you can use as a standard and do the calibration part of the instrument before operating as well. But the operating process is same as that of the hand micrometer. So here what you will be happening here is, I have shown you the diagram here. You will be having the centers in between the cylindrical object could be clamped, and then reading is taken by the vernier scale. So first you will be having the measuring anvil here. The standard cylinder will be clamped here. So this is the holding center which holds. So you have two holding centers, 1 and 2. So in between you will place the standard cylindrical standard. Okay, then you will get the reading in the vernier caliper, and then you will remove the standard cylinder and replace with that of the screw thread. By replacing with that of the screw thread, then you will rotate and clamp exactly where you need to determine the major diameter, and you will get the reading D1 and D2. So this is how the major diameter is determined by using ordinary hand micrometer and bench micrometer. So next is measurement of minor diameter. So minor diameter also we have defined what you mean by it. So there are different methods which are used to measure the minor diameter. So for measuring minor diameter of external threads, two methods are available. One is 2V piece method, and other one is by projecting the thread on the screen. So these are the two methods. So again, for measuring minor diameter of internal thread, you have two methods. One is using taper parallels, and other one is by using rollers and the slip gauges. Okay, so this is for 2V piece method. So what's happening here in 2V piece method, you can see. So you'll be having the micrometer anvil and with the V piece which touches. Okay, so this is the cylindrical standard. So what we place in between first to check the comparison with the standard, and then you will replace that with the screw thread and find out the minor diameter. The major diameter will be at the top of the crest, minor diameter will be at the bottom of the thread which connects between the roots of an external or an internal thread. So what happened here is the minor diameter of the V screw thread is measured by a comparative method using floating carriage diameter measuring and two small V pieces. Okay, so now we are focusing on the 2V piece method. So this will make contact with the root of the thread. So this V shape will help in contacting with the root part of the thread and not the crest part of the thread. So after it is in contact with the root part of the thread, the threaded workpiece is this will make the contact with the root part of the thread. Yeah, the threaded workpiece is mounted between the center of the instrument. Yeah, I have told this already. Then the reading of the micrometer is taken after this threaded workpiece is replaced by the standard cylinder. The procedure, whether it's of any equipment, the same. First you will keep the standard cylindrical object. You will measure the dimension for the minor diameter, and then again you will place the screw thread, and you see that the V pieces are clamped exactly to the root of the thread, not to the crest of the thread in both the directions. Then you determine the minor diameter. Okay, so minor diameter of the thread will be approximately equal to D plus or minus of R1 minus R2. So R1 is the value what we get with respect to the standard, and R2 is the value what we get with respect to the screw thread. So this will be the standard.
Ma'am, your voice is getting cut.
Now is it audible? Hello. So the value
Yes,
of,
ma'am.
thank you. So the value of D is equal to plus or minus R1 minus R2. So this is how you determine the minor diameter by the 2V piece
Ma'am,
method.
can you repeat what R1 is and what R2 is?
See, the R1 is a minor diameter what you get with respect to the cylindrical standard. So you will clamp the V piece. So this dimension will be almost equal to the imaginary cylinder of the minor diameter, the cylindrical piece what we are using. When you are using for the major diameter, you will use the cylindrical standard with respect to the outer diameter. And now we are comparing with respect to the minor diameter. So the imaginary cylinder what we consider is with respect to the diameter of the root and not to the crest. So same dimension thing is used here as a standard cylindrical object, and we will measure the minor diameter. Okay, so that will be the R1 value, and then you will replace this cylindrical standard with respect to the screw thread in which you have to measure the minor diameter. So then you will get the value of R2. So if there is any difference, you will come to know R1 minus R2. If there is no difference between R1 minus R2, then the value of D, the standard cylindrical object what you used, is exactly accurate without any errors. So means you are achieving the value of the screw thread with respect to the standard without any deviation. So if you have deviation, then it shows you the plus or minus value. So this is with respect to the 2V piece method. So next is by projecting thread on the screen. So here what happens is, if the threads are very sharp or have no radius at the root, we use with the help of projection thread on the screen. So the measurement of the minor diameter is done by projecting the thread form on a screen. The projected form is compared with the use of tool maker's microscope. Here the projected form of the thread cannot be done by using projecting thread on the screen. So we will go for tool maker's microscope that we have in the further studies. Okay, so here we have tool maker's microscope. In this part I will just explain you. So here it is just to show which method is used. In depth, the method how we follow will be explained later. So I'm just showing the other method here is by using the projecting thread on the screen, which will be well explained by using tool maker's microscope. that you have in depth with respect to the construction, working and the application. So we'll be dealing related to that further. So the next method to determine, so this was for determining the minor diameter. Similarly, for the external threads. Next you have to see measuring the minor diameter for the internal threads. So for the internal threads we use taper parallel. So this is one of the method, and the other method is by using rollers and slip gauges. So using taper parallels, what we do is, so for the internal thread of the minor diameter, less than 200 mm is measured using taper parallels. So this method is convenient if you want to measure the minor diameter of dimension less than 200 mm. If it is more than 200 mm, you cannot go with using taper parallel methods. So the taper parallels are the pairs of wedges. So it will be having the wedges, okay, parallel outer edges. So these are the wedges where you will be having the upper and the lower part. So the taper parallels are the pairs of the wedges having parallel outer edges. So you will be having the parallel outer edges, and these taper parallels are inserted inside the thread. So here this is a standard cylindrical object. Later you can insert that with respect to the screw threads. So when you have a screw thread, you will be having the helical grooves. So this wedges will pierce inside the helical groove and help in determining the minor diameter. So the taper parallels are inserted inside the thread and adjusted until firm contact is not established with the, until the firm contact is established with the minor diameter. It is not. So it will pierce inside until you get an firm contact between the minor diameter to that of the wedges. So once it is done, then the diameter of the outer edge of the taper parallels is measured using the micrometer. So this will be connected, the wedges will be connected to an micrometer. It could be an hand micrometer or a bench micrometer, whatever. So that helps in providing the reading of the minor diameter. So this is one of the method to determine the minor diameter in case of internal thread. So this is not applicable for the external thread. So next method to measure the minor diameter of the internal thread is rollers and slip gauges. So you know what you mean by slip gauges already. We have used in measurement of the linear and angular measurements. So this method is used for the diameter which has more than 20 mm diameter. Okay, so here you can find the precision this one rollers. These are inserted inside the thread. So you will be having the thread. So these precision rollers will be inserted inside the thread. So when you have, so this will be the cylindrical object. So you will be having the internal threads here. So inside the area what you have in between the internal threads, you will pierce this cylindrical rollers. Okay, so then what happens? The precision rollers are inserted inside the thread and proper slip gauges are also inserted between the rollers because it has to be held firmly. So you'll be having two rollers and the slip gauges. So you will add on slip gauges until you have a continuous contact between the two rollers towards your internal thread from this end to that of the this end. So to keep it fit, you have to add that much amount of the slip gauges by trial and error. So then the length of the slip gauge plus twice the diameter of the roller in the minor diameter will help you in determining the minor diameter of the screw thread. So this is possible only for the diameters having more than 20 mm, not less than 20 mm. Okay, so you'll be using two rollers and the slip gauges. Finally, the length of the diameter of the two rollers plus the dimensions of the slip gauges will provide you the required value of the minor diameter. So this is the method which has been used for determining the minor diameter by the roller and the slip gauges. So next is measurement of effective diameter. So the effective diameter here could be measured by two methods. One is the thread micrometer and the second one is a wire method. So wire method is again a vast bifurcation where we have two wire method, three wire methods, all those stuffs. So whenever it has been asked to determine the effective measurement, then
Time up.
you have to, hello? Yeah. I will continue this in the next class. So to measure the effective diameter in between the major and the minor diameter, we use thread micrometer or the wire methods. So this distance between major and the minor diameter will be provided by the pitch diameter. So if they ask you to show the effective measurements for the pitch diameter, then you should explain the thread micrometer as well as the wire methods. So this I will continue tomorrow in my class. So today there was many disturbance in between. I'm sorry for that. I don't know what's the reason for the internet instability from my end. But hopefully, I hope you have understood the concept related to the terminologies of the screw and different methods what we have to follow for measuring the major diameter as well as the minor diameter of the given screw thread. And in the next class, we'll see the instruments which are being used in order to measure the pitch diameter and also other parameters as well. Have everyone added your names in the chat room? Anyone else who haven't added? So please add on your USN number in the chat quickly. So we'll see you in the next class. Hopefully I have my class tomorrow at 9:30, right? Any doubts you
Yes,
have
ma'am.
to clarify? And listen, around
No,
12
ma'am.
students haven't submitted the assignments yet. I'm not waiting more. I'll just put directly 0. I have posted them a message also in the Google Classroom. They haven't turned up yet. So please inform them. It will be directly 0 for the assignment one. So plenty of time was given, but still they haven't turned up. So I don't know what's the reason is. Just inform them. And you are free now to speak any problem you are associated with or whatever. Yeah, Akram. You want to speak something? Any doubts?
No, ma'am.
Okay, hope the concepts were clear. You should just brush up thoroughly uh, and understand the concepts, and you have to draw the sketches very neatly if you want to get good marks. And you have to improve the handwritings also. So if anyone have not entered the USN number, kindly add on, or else shall I save it, your names with the USN number? Everyone have given your names? Fine then, thank you all. Have a good day. We'll see you tomorrow by 9:30. Fine.
Yes, ma'am.
Yeah, Chinmay, you want to
Yes,
tell
ma'am.
something? So be safe.
No, ma'am. I just.
Yeah, be safe, be careful, and do
Okay.
all your assignments on time. And hopefully to see you all early in the college back. Hopefully after 14th April might be. Let us see. Okay.
Okay, ma'am.
Yeah, fine. Bye bye. Take care, everyone.
Thank you,
Thank you,
ma'am.
ma'am.
Yeah. See you tomorrow then. Bye bye.